This session is Staying Persistent in Software-Defined Networks, and this is your speaker, Gregory Pickett.
Okay. Well, first off, thank you for coming today. This is indeed Staying Persistent in Software-Defined Networks. My name is Gregory Pickett with Hellfire Security. I am part of our cybersecurity operations group. An overview of today's talk: WhiteBox Ethernet. What is it? It's very new to people, so we'll talk about that just a bit. After that is stupid is as stupid does. Exploiting it is next. I'll point out a number of weaknesses. We'll take advantage of those weaknesses and see what we can do with them moving forward. How do we address those weaknesses? We'll deal with remediation. We'll deal with mitigation, damage control, right? And then wrap up with some thoughts on where this is all taking us and why we find ourselves in this kind of position again. Right? All right, so let's start with WhiteBox Ethernet. WhiteBox Ethernet is standard hardware. It's really just a blank slate running merchant silicon. Tried it in Broadcom chipsets, Intel, AMD, and PowerPC processors, using an open operating system, often Linux-based. The idea is to remove the hardware from the equation, okay? To make it a commodity by using off-the-shelf components. So from that point forward, it would be the software that makes the difference. Right? It's critical for software-defined networking, but it can be used without it. Okay? So why do it? For the same reason that you would implement software-defined networking. Reduce costs, increase flexibility, gain more control. You can gain the control in a more traditional fashion. You can use it like a regular switch. You can connect with SSH, issue commands to define the switch, to configure the network, script it for management purposes. You can gain the control with DevOps, install an agent like Puppet, Chef, or Ansible, have it managed with the rest of your infrastructure. Or you could gain the control with software-defined networking. With software-defined networking, the control plane is centralized in the controller. This makes the network flexible and responsive, which is what they're going for, obviously. Right? With WhiteBox Ethernet, your hardware or data plane then becomes just as flexible. Right? You can just exchange those whenever you want. You don't have to be tied into any sort of vendor, their technology that's proprietary. Right? You are truly free of that hardware. Okay. All right, so open network install environment. To facilitate the plug and play of that switch, right? To make WhiteBox Ethernet truly be able to interop with that network and do so in a very seamless fashion, ONIE was adopted. Okay. ONIE is firmware for bare metal network switches. There is grub and U-boot underneath to boot the system, but then ONIE is there to boot the network, right? It's there to facilitate the installation and removal of network operating systems. It comes pre-installed because it is part of the firmware, and it's really there to automate that switch deployment. You plug it in, ONIE installs the network operating system, the switch kicks off and just runs, right? It becomes part of the network. Very easy, very fast. So, WhiteBox Ethernet, the blank slate, and ONIE the network bootloader, right? What could go wrong? It turns out a lot of things. Starting off with ONIE, right? Its operating system, ONIE itself is based on Linux. Privileged account has no root password, it's blank, and there's no force, right? It doesn't force you to change it. So that blank password is likely to remain stale. Management services are also weak. Telnet, of course, by definition is insecure, therefore weak, and SSH, right, the keys are weak. 18 bits of entropy on the installation mode, 26 bits of entropy on the recovery mode. So it's not looking good so far. Right? The installer. Not looking much better. It uses a predictable set of URLs that are actually defined by the standard. This is where ONIE is going to look. Step 1, Step 2, Step 3. You know this ahead of time. Anybody does, right? It will get an exact URL from a DHCP4 assignment. It will build a URL from the DHCP response. It will then look for IPv6 neighbors. Hey, do you have an installation? And then it'll go through a waterfall with TFTP. Now, when it follows this very predictable and very knowable path, it also looks for a predictable file name or set of file names. It starts with one file name it looks for, then another, and another. What this means is you can then be in front of ONIE. You know where ONIE is going to be. You can be in front of it, and you can hand it whatever you like, and ONIE will install it. No questions asked because there's no encryption nor any authentication. So if you happen to give it a compromised one, it will install it. No questions asked. Compromise install. All right, now the implementation is where we see more opportunity for things. Because once ONIE has installed the network operating system, its partition, that aspect of the firmware that is ONIE, is exposed. And there's no secure boot. So should ONIE be modified, there's nothing to stop that modified ONIE from operating again and again and again and doing whatever maybe an intruder has told it to do again and again and again. So what does this mean, of course? Well, that there's lots of opportunities to blow up ONIE. Lots of ways to get at ONIE. Here's how. Obviously, we're going to talk about the different ways to do it, and ultimately, what I find to be the best way. You could, of course, compromise it directly with a blank password that's likely to remain stale. You could wait till it's up, log in. You could snip its traffic, put man in the middle, whether on the telnet or you crack SSH and perform the same operations. That's highly unlikely, though. ONIE's up for 0.00, I'm just throwing numbers out randomly here, 0.001% of the time, right? It's there to install the network operating system. After that, it sets a boot variable. It says basically from that point forward, you boot to the network operating system, reboots the switch, and then it's the network operating system running 99.9999% of the time. Right? So not really feasible or ultimately practical. Well, then you could take a look at maybe being there at the right time, right, to compromise an installation. Be a rogue DHCP server, be a friendly IPv6 neighbor, or just spoof a TFTP server. But that's still got difficulties, lots of difficulties. You have to be there at the right time, right? And even if you are able to get it to install a compromised installation, what about next time? Right? It's once again like a lottery, right? You have to be there at the right time. Not a real good approach. Best one is look at those network operating systems. Right? Compromise it indirectly. Wait till the network operating system is up and running. Get past the network operating system. Modify ONIE. Right? The partition is exposed, waiting there for you. And because there's no secure boot, anything that you do to it will continue to be enforced, to continue operating. Right? So any sort of compromise that occurs to it will stay. It will stick. Right? We like that. And now you're in the firmware. Right? That's why it sticks, and you are there forever. Right? Not exactly forever, but you get the long-term view there. Right? You get that long-term X, and that's really what you want as an attacker. You want persistence. You want to be able to hide as deep as you can, so you can stay there as long as you can. Okay? So, we want to then take a look at the network operating systems, given that ONIE is pretty much defenseless there, to see how well they're doing in protecting themselves and protecting ONIE. Right? What do we have to get past to do this? So the network operating system at that point becomes very important. It's a linchpin for all of this. All right, so network operating system gets installed by ONIE. It operates the switch. There are, turns out, a whole lot of network operating systems. There are only a handful right now that have ONIE-compatible distributions. The number's growing, but only a handful right now, because now's a good time to talk about it, right? At the time I started looking at this, we had Open Network Linux, SwitchLite, Cumulus Linux, and Mellanox-OS. Okay. Open Network Linux, it's a Linux distribution for bare metal switches, as they all are, obviously, based on Debian Linux. It's bare bones with no features, right? Means it will run the switch, but you'll have a real hard time defining the switch, a real hard time configuring the switch. It's because it's really just a reference, right? The Open Compute project, which has adopted ONIE, said, here you go. Here's a starter. Use it to develop your own network operating system. They want to promote ONIE, right? So SwitchLite said, okay, we'll do that. I looked at SwitchLite 2.6. It's a packaged Open Network Linux. SL REST is actually added, it's on the slide there. It works a lot like OVSDB to define the switch. Indigo OpenFlow agent is added to allow you to load the flow tables, configure the network. It is an extension of Big Cloud Fabric, so it's not standalone. It's part of this bigger solution by Big Switch called Big Cloud Fabric. You basically plug the switch into the network, and Big Cloud Fabric takes over. You are actually actively discouraged from managing the switches. They kind of want you to walk away, which I kind of look at it as abandoning my switch. We'll see if that's a really good idea for you to walk away from that switch. Okay. Then we have Cumulus Linux, looked at version 2.5.3. It's real critical, right? That when they look at these things, they want to make sure, right, that you're looking at the most current version. So we'll always put these up there. So version 2.5.3, also based on Debian Linux, Puppet, Chef, Ansible. That's what you'd install because it's meant primarily for a DevOps environment, right? Automation and orchestration, maintained by Cumulus Networks. Third one was Mellanox-OS. There are 4, but 3 that really count. Mellanox-OS, version 3.3.4. There is a 3.4, which I should mention, but they do release this, so it's fair game. And it turns out that a lot of the problems that you see in 3.3.4, well, they're the same problems you have in 3.4. So you install Puppet, Chef, or Ansible on it to make it part of a DevOps environment, or eSwitchd to make it part of an SDN. So it's really much more flexible than the others. Maintained by Mellanox Technologies. Right. So we'll start off with the agents. Right? The real problems are in the OS themselves, but the agents needs to be mentioned. There's no encryption, no authentication on switch like Indigo, nor Mellanox-OS's eSwitch. With Indigo, you do need to spoof the controller, but after that, you're home free. eSwitch, you just need to talk to it. Hello, and it'll do whatever you tell it to do. Okay. And to balance out the slide, because I didn't want a big blank space there, I just threw this in here. I know that OpenSSL could use updating. Let's put it that way. I did check it for Heartbleed. They did patch that, but still it's a little old, and I like to make sure these people move on with this stuff, right? Move up to the later versions. So it's there. All right, immediately, right? The common problem among these platforms, especially when it comes to southbound APIs, is problems with encryption and authentication, which means that you have a good opportunity for topology flow and message modification through unauthorized access. Right? Add X, remove X, hide traffic, change traffic, or some of the people have been talking about, eavesdropping. Right? Eavesdropping, and it's going to be an issue with SwitchLite and Mellanox-OS when using it on a software-defined network. But there are bigger problems, and this is where things begin to escalate, where we start looking at getting that persistence, right? Getting onto the switch and getting in the firmware and being persistent. Okay. All right, so we talk about the OSs. We talk about first the default and fixed accounts. I'm bringing these up for 2 good reasons, right? There's 2 reasons why this is such a big deal. The first is there's a limited ability to add other users. So you are kind of stuck with these accounts. The exception is Cumulus Linux, but there's some command injection that will allow you to get around that. Right? So for all intents and purposes, you are stuck with these accounts. Second reason is they are the only obstacle between you and getting root on the switch. All right? The only obstacle. Because once you have that account, and I'll be doing that today, all right, doing some targeted keylogging, not too hard to do, but there's lots of different ways that you could get in a foothold. But once you get that account, this way or another, it's smooth sailing. There's an easy escape to shell. SwitchLite has a wrapper, but the wrapper is easily left behind by typing in enable and debug bash. Cumulus Linux, you deal directly with the operating system. There is no wrapper, so you are just there at the shell. Okay. Mellanox-OS, there's a wrapper, but you have Puppet there. You can configure Puppet. And you can make Puppet do all sorts of things. Right. Now, they did a good job with it. They actually had some foresight. They limited what Puppet could do. I tried to screw with password file, right? Shadow file, but I was denied. It turns out, though, if you unpack the firmware, you can find all sorts of useful things. So I found something there that I could start as a backdoor that gave me my shell access. So I like that very much. All right, and then once you have the shell access, it's pretty much instant elevation. With SwitchLite, it turns out that non-privileged account, because those accounts that you're working with every day, are, once you're stuck with are the low privilege accounts, they're supposed to be, right? Turns out that low privilege account admin is actually UID 0. I was talking to a lot of people about this before, and this really is about a lot of bad decisions, right, on the part of the vendors and what the implications are. This is the first of many. So UID 0. Cumulus Linux, you get to sudo everything. You have free reign with sudo, so you are basically root equivalent there. Also not wonderful. Mellanox-OS, you're using that low privileged account, the lesser privileged account admin. You start the backdoor. It's obviously started with admin's privileges, and you have your shell. And you check out your ID, your UID, and it turns out you're also UID 0. And so you are then root again. Not a great idea. Okay. So really, that's the only thing standing in your way is that one account. You get that one account, which is trivial to do. Full control of your network through unauthorized acts. You obviously start out with the switch first, then it's the network. Do everything you could do before, right? Add X, remove access, hide traffic, change traffic, eavesdrop, whatnot, and all three operating systems. Because it's such an easy path all the way in to root access once you get past that. Right? And of course, the ability with root access to compromise the firmware and to get that persistence. So we start talking about the implications, right? Like dominoes falling over, and at the very end of the dominoes, things kind of blow up on them. So this means that your network, is 1 keylogger away. Okay. All right, so I'm going to go ahead and run through some screenshots. Last year it was, those are open source products. What can we expect from open source? Or open source is always catching up. Or you pay for the product, right? You pay for a higher quality. Well, okay, I'll do vendor products this year. All right, we'll show you those. So I went ahead and have the vendor products running on switches, and I want to screenshot those. So we have, starting out with big Cloud Fabric controller. I think with these sorts of things, you start to piss people off. I got a lot of interesting views on my profile at LinkedIn this week, so yeah, I think I'm pissing some people off with this. So you go up there and you log in with the low privilege account admin, and you go through the available commands, and I found a really interesting one called debug bash, which I like. And then I went ahead and got to the shell, and if you're paying real close attention to the account slide, you saw the root accounts, they were hidden and disabled. Okay? They really don't want you near the switch, at least they discourage you, especially in the case of a switch light, they discourage you. So they gotta hide that away from you. The fact of the matter is, if they hide that from you, you're not likely to set that password. You're not likely to make changes to the account to harden it. So if you are looking close enough, you'll realize that that hidden account doesn't have a password set. So you can just go ahead and just switch user. Because all it does is keep you from logging in. Once you're logged in, you have ability to access that account, and if there's no password, you become root. And I said, I wonder if I can do that on switch light. Turns out you can. All right, so admin, I had to put in enable first, a little extra work, then debug bash, and I came out just as root, and I was a little bit surprised about that. And then I took a look at the password file, and it turns out I am UID 0. With the home directory of root, I'm pretty much root equivalent there. Okay. And then once you have that root access, you can take a look at the different flash devices there, and you got MTD info and the permissions that I need, obviously, for write or the root account, and so I have that. You can see that. I should put more red circles up there. So, then Cumulus Linux, you can sudo, as I say, sudo it up. You can cat etc shadow, you can change the password of root, you can change over to root, right? And yes, this one. So I started the backdoor, and I will tell you what that is. I might make other people mad now after telling you that. So you start that up, and you add, who am I, just as a check there, and then you cat etc password. And turns out I'm UID 0 there too. There's another account actually there too that's also UID 0. So shell with root privileges. We like that. All right. Now I mentioned command injection before. And it involves Cumulus Linux, so I'm very sorry, Cumulus Linux. They've already been notified. So actually a patch came out on Friday. A patch on Friday for this. Now I don't come up with too many like zero-day exploits. I don't come up, I'm more of an operations guy. As I said, I'm part of cybersecurity operations, so I like to show off a little bit when I do. Big banner, that sort of thing. I celebrate this, I guess, a little bit. All right, so Cumulus Linux has several command line tools. I won't rattle them off. They're very, lots of tongue tying right there. All right, so they have these tools that are meant to be used by low privileged admins. Right, the idea is to scale back sudo for maybe you add another user, right? And you scale back sudo and you say, we're only going to give you access to these tools to define and configure the switch. Right? So these tools take in arguments. And the arguments end up being subcommands and parameters, right? They pass through to CMD server, and there's what they call Rosetta. If you go through the code, there's a Rosetta, and they compare it against that. And anything that's not on the Rosetta gets filtered out. Problem is there's command injection issues, or there were until Friday. Command injection issues that allow you to bypass that filter. And because CMD server runs as root, you get to pretty much escape any of those pseudo limitations. And anything you like is root. Okay. There's another switch running the software, because I tried all this, of course, on live switches first. I didn't bring one with me. I'm not as resourceful as the gentleman who brought in, I don't know if it's the Black Hat or DEF CON, they're bringing in a whole safe. As I said, no, okay. I'm not going to try to get that thing on the plane or try to pay for it to be shipped, right? For the thing that I have this top rack switch for this. But I wanted to show you that it was running. There it is, with the license installed. And we'll demonstrate. Go. So this is actually just a VM here. And being that I have lots of VMs running right now, it's a bit of a delay. It'll come up though. There you go. Okay, so I'm going to go ahead and I'm greedy. Cannot, obviously. All right, I only have access to those 5 tools. But maybe I know about the command injection. So we're going to go ahead and grab that here. I'm so glad they have a patch. There's no mystery there. Can everyone see this? I made sure they're larger font. All right, so we have the tool that I have access to, or access to sudo. And I'm going to go ahead and inject by making my injected command look like part of the label. In order to do that, I need to leave out spaces. But that's easily overcome by creating a script, right? In my one little lonely home directory, and then injecting a script. It does say unknown command because there aren't really any switch guts back there, but it injected nonetheless. Oops, wrong one. Here. So now I'm going to go ahead and try to go after that shadow file again. All right. So yes, you just, thank you. So that's why you get 0 days. It's not. It's for the collapse. All right. So easily bypassed. I'm going to go ahead and exit and then pause that VM because I want to make sure I have the resources for. There you go. for the next demonstration. All right, so once you have those root privileges, you can go ahead and take a look at the MTD devices, right, the flash, and there's your ONIE, and then you can use sudo, of course, right, dd to dump it. Okay. And then have your way with it. All right, so we're talking about implications of all this, right? What does getting past that one account mean, and how easy is it to do this? They always talk about they're safe, right? They're safe because they're behind a firewall, and the only thing that touches it is Windows, and they're running Linux until they're safe, and so we want to take a look and see how feasible this is. So I'm playing the GOTEED network administrator. All right, talk about network administrators because they have feet in both worlds, right? They have that foot out onto the internet, they have that foot into the control plane. So they have great points to pivot. You could web browse and get a drive-by download. You could open an email, with open an attachment, whatnot. There's a million and one ways, right, to get that foothold. Other sorts of talks about that. I'm going to do a malicious attachment. So I'm going to open that up, and it'll be Big Brother. Big Brother is going to be there. It's a Windows-based binary, infect the Windows system. It's going to do some targeted keylogging, waiting for the use of those default accounts. Now, I did that to make it simple, but you could have easily keylogged on connection to the switch. All right. So once it gets those credentials, it will log into the switch and write a Linux-compatible binary to the file system of the switch. Doesn't need to download anything from the internet. It's actually carrying this payload. The secondary payload is called Little Brother, right? And Little Brother gets started as a backdoor. Then Big Brother unpacks ONIE, shoves Little Brother in. I mean, what are Big Brothers for, right? To mistreat Little Brothers. Shoves it in there. Modifies ONIE. Modifies ONIE NOS install. Anytime you put another network operating system in there, go ahead and put Little Brother back. Okay. Wraps it back up, shoves it back into the flash there. And then it does a pivot. It connects to Little Brother, then pivots out to the internet or anywhere you want to go, right, to get past any sort of VLANs, ACLs, firewalls, that sort of thing. And it's really nice. It uses an HTTP reverse shell, so it browses. And it browses using headers. I'll try to blend in. And it will use proxies. Right, so a user proxy will do its best to mimic a user. Right. So we'll go ahead and demonstrate, because the whole idea is to have a way for that backdoor then to reach out to the internet, right, and get that access to anybody out there who might be waiting for it. So I'm going to go ahead and set up that guy. I need to make sure he's going. There he is. Okay. He hides a little bit. He's not very good at hiding. I'm not a malware specialist. All right. So he will pop up there for a second. All right. So that's going. And you as the network administrator, me in this case, is going along doing whatever I do. And then one time or another, I'm going to log into my switch here. I think I already had that there. Yeah, finish it. And I put, this is demo OS, but I put up on it a wrapper just like switch lights. See why they hate me? All right, so we go ahead and we do enable. This, of course, is just extra, right? Big Brother has already seen the credentials. It's off and running. This is the way to distract you. It takes time for that to do that. All right, so there I am. I can do whatever I want to do, right? On that switch. And I need to define it, configure the network, whatnot, and get off. So we're going to head over to the C2. Make sure everything is going okay. C2 takes a bit to catch up. I'm going to take the time here to do this. right, that's good news. All right. In these talks, you always have to double check things. Things break down. All right, so you can see that Big Brother has done his job. He has started up Little Brother, a Linux binary and that Linux operating system from a Windows host. So it's important to keep in mind, right, that the Windows system is not an obstacle. Connected back to C2. All right, that's who I am. Gonna back up. There's some timing issues. I just make sure that the exchange is able to complete. So from that C2, I'm able to, from anywhere, right? So this right now is relaying from a VM to the Windows, so a Linux VM to the Windows host, out to a Linux C2 server, and that could have been, anywhere. So there I am on the switch from remotely, right, from outside that network. At some point in time, network administrators, they're on the ball. They're going to take a look at that switch, and they go, "Well, that looks funky," and they're going to reinstall, because that's what we do now. We don't generally clean up so much as we wipe things out. We find out what's going on, and we wipe things out. So let's go ahead and do a wipe out. Let's reboot this and install a whole another operating system. So we're going to go through that process. All right, I'm freaking out because I got a back door. I'm going to reinstall that. I'm going to go ahead and get my path. By the time it should be up. That's just obnoxious, so. I think this is going to kick off. It's going to do whatever it does, right? It's got a whole process. I'm going to start back on the presentation, and then we can go back and check to see if Little Brother is able to resurrect. I'm pretty confident he will. All right, so available solutions for all this. All right, these are, as I said, a list of maybe bad decisions. There's a harsh word, maybe poor choices, right, by the vendors doing all this. Just talking to them, it seems that they're looking for, ONIE is looking to network operating system to protect it. Network operating system is assuming that your customer, right, is going to do all the right things. It's a perfect world. Then any solutions that you have are going to catch everything that might possibly show up. They're all kind of like, I don't know, passing the buck. Right? There's reasons for it, right, in business, why you make certain assumptions, right? They have them, and this is where we end up. But we have to remind them about choices and their the implications, right? So we talk about available solutions for all this. Get them to catch up to these sorts of things. All right, so hardware, install environment, network operating systems, agents, and then enterprise architecture. The hardware, trusted platform module. That would really help out a lot. I'm sure it had with a big switch had these put in most x86-based switches. We need to get them on PowerPC. There aren't any that I know of. I've spoken to a couple people that are in the works, so maybe it's not such a big deal. But if there are any PowerPC switches in the works, new ones, they should also have TPM, and we can start using them. ONIE is actually working to get this part of the standard. All right, so there's some relief ahead. ONIE is run by, or started by Cumulus Networks. Install environment, right? Ways to add resilience, right? Beef up the different components here. Starting with the install environment, remove telnet. I don't see why we need to have telnet on there. I think we can all use SSH, increase the key entropy, force a password change. We can remember passwords. We're pretty good about that. Or if we choose not to, there's things called password safes. And I know hands out there. Have anyone out here done a factory reset? Right? You factory reset these things. That's why they're there. Right? Not too many hands. I think maybe some of you are not being honest. All right, so remove IPv6. TFTP waterfall would be a good thing to do. DHCP, there's nothing wrong with that, probably in the URL there. We can protect, hopefully, our DHCP server to make sure it's the only one assigning addresses. And I'd like to see the installations being signed. I know there's always complications, right, with keys and getting signed, but that would go a long way towards solving that one part of the problem, right, which is the fact that this kind of installs anything that you give it, right? Sign installations would resolve that. Network operating systems. Before we start on that, let's see what happened with our compromised ONIE. I'm going to go check back with the operating system first. So the operating system is back. I should say it's been installed again. Let's go back to RC2, see if we can get that connectivity back. Now, I know that that's been disrupted, so I'm going to go ahead and send a command to Big Brother to tell him to reconnect to Little Brother. It's going to close his end of the socket, and then open it again with a fresh install of Little Brother. All right, so my access is still there. And I can just still do whatever I want to do. What, no claps for that? Thank you, thank you. I worked so hard for so many months. Just want a couple claps. All right, so go back to that network operating system. There are a number of things that can be done there. Obviously, there's varying degrees of contribution. But we look at anything that we can do to strengthen that operating system because so much relies on implications, right? So anything we can do to strengthen that network operating system. Tangible names on UID 0 accounts, to reduce privilege accounts. I think something better would be being able to add users. Right? SwitchLight, you actually can't add users. Right? With Mellanox, you can add users, but you have two choices. You have admin or monitor. Which one do you think you'll use to take care of the switch? Right? That's the one that's going to be exposed. And from there, you could, of course, then change passwords and change passwords of the original admin account to get your UID 0 back. All right, so there you are, stuck with that thing again. Right? So add accounts and make sure that accounts you can add have less privileges or able to truly have less privileges and be functional, right, when doing so. Also, we'd like to see UID 0 removed from admins, right? And then tighten the shell access. SwitchLight, you want to give access to the shell. I understand why you do, because they do have it there, even though they discourage you. One-time password is an option. All right, we have the self-service portals. I can't you self-service yourself a one-time password? All right, keep the people off that. Just make them, well, they really need it, they'll go through that hoop to get that. Cumulus Linux, a wrapper, is a good option. One-time password with that. And here's the big secret that may end up pissing off Mellanox. Right? SOCAT. All right? Not quite as popular as Netcat, but it's there, and you can start that up, and you can plug it into Bash, and there's your backdoor. Big secret there. And so remove SOCAT. They actually do a pretty good job of protecting their shell. Hidden in there, though, is a way to access the shell through the wrapper. I was just taking a really long time to reverse engineer their wrapper, so I went for SOCAT instead. And then agents, of course. Use the TLS. And not just use it for encryption, also for authentication. I know we're all worried about certificates and key distribution. You got DevOps there, you got Stan there. They're there for the heavy lifting, right? Have them do the heavy lifting for the certificates and the keys, too. Right? Enterprise architecture. The first four are remediation, right? Vendors start changing things, make the platform a stronger platform, more resistant to compromise, keep people like me away from ONIE, that firmware. But you have to, in the meantime, do mitigation. And what you have to bring up then, isolate the management plane again. I think it's quite common to have it open. It's quite common to have it just being protected by VLAN. But there's a way to pivot around that. We go as close as you can. I understand it's difficult to make it physically isolated, but get as close as you can. I don't see a reason why you can't use the jump boxes, right? Get as close as you can to a physical separation. Have a jump box. Has anyone here been to network operations? Have a network operation? You see how many monitors they have in that place? There's like 20 monitors in the wall. The network technicians, the administrators, they have like 2 monitors on their desktop. Why can't you have a jump box? You remote in a jump box. You maximize that and that one monitor, and you're using it just like you would your own station, right? We have to do what's necessary, and we have to bite the bullet in some cases to protect our networks, right? So we need to add these layers of defense. And then audit switches, right, which is, of course, the A word. I had to learn to love audit. Password changes. Make sure passwords are being changed comprehensively, not just on the enterprise applications and the OSs, but also the network operating systems, also on the switches as well. And then hashing the ONIE partition would not be a bad idea either, right, to make sure it hasn't changed. So racing ahead, I mean, these types of stories have been told before, right, vendors and their poor choices, and it's about racing ahead. And we're here to talk again about impact on security and keeping pressure on developers and the difference we're trying to make here. Okay. Getting products and features to market is important. I get it. We all get it. Right? But desktop operating systems and server operating systems have been through this before. They've come up with best practices. I would like to see you read those best practices. I'd like to see you create some of your own and then start using them. Because that's not happening, then we start the merry-go-round. Right? It happens every year at these events. We hack it, you fix it, right? Clean up, panic, and then clean up. Right? It's important that we hire someone for security. And the reason why I point this out is because a lot of these companies are startups. Right? Or it's a small unit within the operation, not working with a lot of people. 200 people, right? Maybe 200 people, let's look at just a startup situation, one for security. Maybe bring an outside company to check it out, an assessment midway through. These are not new. At the end, before release, we would actually just settle this before release, right? Someone to look at this, outside eyes. Because if you're talking about startups, talking about small business units that have improved themselves, it's more expensive, that's what we're told, right? It's more expensive to fix it later. Why don't we then fix it now, before we release it? Because when you do go try to sell it, and you do try to promote it to sell it, security can be a feature too. Right? It can be a feature too. So here to make a difference, we want you to learn from the desktop, okay, me, but the broader audience, right, the broader community, want you to learn from desktop and server operating systems, right, the vendors, and leverage those management platforms. The idea is for these platforms, whether they're DevOps or controllers, to take over. What we see them doing is taking over the definition of switch, we see them taking over the configuration of the network, but they're kind of dropping the ball when it comes to the OS themselves. There's no reason why there can't be some sort of reference, right, between the two. There's no reason why there can't be some sort of auditing, right? Plugging into the auditing events, looking at those events, looking at the state, what's been going on ultimately on the switch. There's no reason why you can't have some sort of look at the logs, or at least some kind of consolidation where you're drawing things up to a platform, right? Maybe not the controller itself, but something secondary. Pull the stuff all together so you have that full visibility across the platform. You're just not focused and ultimately fixated on defining the switch and then configuring in the network. Just broaden it, right? Open that up. And there's no reason why there can't also be logic probes. And this is kind of a general term that I'm throwing out there. A good example is the hash and ONIE partition. Are things the way they're supposed to be? There's no reason why I can't check these things. This is critical, right? You are getting persistent. You're getting the persistence in an area where you have full access to the traffic. It's important to take these extra steps. Okay. So, always obligatory final thought slide. We're about done here. We'll open up questions. The security of the network operating system is critical. Right? However, that security is neglected. Is often the case. They believe that the switches are safe. They're, for the most part, relying on that customer, and they rely on the customer to have everything just right, and the solution to operate in a perfect world and catch everything. And as we know, things are often put together by attackers, right? They get by one obstacle or another, and right? So you can't assume that one thing in front is going to keep everybody else out. Right? A single piece of malware could easily make the crossover from Windows. It's not safe behind a firewall. It's not safe just talking to a Windows box. The malware can make the bridge. It can go to a Windows system and then over to a Linux system. Okay? When it does, it leaves you with a persistent presence on your network with that full visibility. Right? Or any number of things that can be done. They brought that up, I guess, in this article about bricking the switches, right? So I talked about you could turn this into a worm, right? And they said, well, could you turn this worm into something that maybe brick the switches? I say, why not? Why not? So this could be bad. Let's get this fixed. These are links. They're attached to that. All this good stuff that you can take a look at. I believe All this is posted on the website afterwards. You can take a look at it then. But that is it. There we go. Oh, I went backwards. There you go. Okay, that's it. Questions? Thank you. You remembered.